Hi there, this is Dr. Rebecca Johansson with the Performance Project. We provide running and triathlon coaching, and you can find us at theperformance-project.com. Today's sports science mini lecture is going to be on detraining in endurance athletes, and we're going to specifically be looking at the changes in cardiovascular variables over time. So this figure is going to be the central figure that we go over as we discuss the topic. So on the x-axis, you have days of detraining. So starting from 0 all the way out to 84 days, which is going to be 12 weeks of detraining. On the y-axis, we have relative change, so percent change in any of these variables. So the variables that we're going to look at today from top to bottom, the red line is going to be max heart rate. The green line is AVO2 difference. So that represents oxygen extraction. So how much O2 was extracted from the blood vessels for use during exercise. It would be going mainly towards the skeletal muscle cells to use to convert into energy. The purple line is VO2 max. The beige line is Qmax, which is cardiac output. And finally, the blue line is SV max, and that's stroke volume. There's two important formulas to go over when we look at this graph. The first one is the formula for max cardiac output, Q. And the formula for that is heart rate times stroke volume. Cardiac output is the volume of blood that gets pumped out from the heart per minute. And heart rate is heartbeats per minute, so it's how fast your heart is beating. And stroke volume is the volume of blood that gets pumped out with each heartbeat. So when those two variables are combined, you get cardiac output. So it's going to be volume over time. When we look at how this changes over time, we're going to be splitting it up from 0 to 21 days and then 21 to 84 days because the changes are very different from the first 3 weeks and then beyond 3 weeks of detraining. The second important formula is the Fick equation. So it's the formula for VO2 max. And that's going to be Q, which is cardiac output, times the AVO2 difference. So VO2 max consists of how much blood is getting pumped around the body per minute times how much oxygen is being extracted from the blood vessels. Now, when we look at the graph from 0 to 21 days, so the first 3 weeks of detraining, we have a significant decrease in max cardiac output. So that's Qmax, and that's the beige line. So it goes down nearly 10% in only 3 weeks of detraining. And when we look at the variables that make up cardiac output, we have heart rate, the red line, and then the first 3 weeks, max heart rate actually goes up a little bit, just under 5%. And then when we look at stroke volume, the blue line, stroke volume decreases a lot, nearly 12% in the first 3 weeks of detraining. So ultimately, you have a large decrease in cardiac output, and this is primarily due to a decrease in stroke volume because the decrease in stroke volume far exceeds the small increase in max heart rate that we see. Now, when we consider why this happens, the decrease in stroke volume is due to a decrease in plasma volume or blood volume. So when you have a decrease in your blood volume, you're going to have less volume of blood entering your heart and thus less volume of blood getting pumped out from your heart. And remember, stroke volume is the volume of blood that gets pumped from the heart with each heartbeat. So stroke volume goes down and cardiac output goes down. When we look at the VO2 max in the first 3 weeks, VO2 max is the purple line, and that decreases at about the same rate and the same amount as the cardiac output. So the decrease in VO2 max that we see in the first 3 weeks is primarily due to the decrease in cardiac output, because the AVO2 difference pretty much doesn't change at all in the first 12 days, and then we see a very slight increase from 12 days to 21 days. So the first 3 weeks of detraining, we've got a decrease in cardiac output and a decrease in VO2 max. Now when we look beyond 21 days, so we're going from 3 weeks to 12 weeks of detraining. So this would really be an extended time of no training. And when we look at the variable that changes the most is going to be VO2 max. So VO2 max, that purple line, from 21 days, you're sitting at around between 7 and 8% decrease. And then when we look at day 84, that individual has had nearly a 20% decrease in their VO2 max, which is huge. And when we look at why VO2 max goes down so much between 21 and 84 days, the reason is mainly due to a decrease in the AVO2 difference. So that green line we see goes down quite a lot between 21 and 84 days, but cardiac output has sort of stabilized and it's not really changing much from 21 to 84 days. So why do we see such a large decrease in that AVO2 difference from 21 to 84 days? That's because you have a decrease in the muscle mitochondria, so they're not able to extract oxygen to as great of an extent, and they're not able to be as efficient. So in the next mini lecture, we're going to go over what mitochondria are and what happens to the mitochondria with detraining and then when you start to train again. So look forward to that one.